Hello, welcome to this On Semiconductor webcast. Today we're going to discuss motor drivers for white good applications, their key features, and where they are used. First, let's talk about energy standards worldwide and why they are important. Governments around the world continue to tighten energy standards in response to rising energy costs, climate concerns, and political instability in oil-producing countries. The U.S. Department of Energy proposed standards for refrigerators, room air conditioners, and washing machines, which in some cases mandate efficiency improvements as high as 35%. These recent changes are just the next step in a continuing drive towards increased power efficiency. In Japan, a country with scarce natural resources, and due to natural disasters, their ability to produce adequate power has been significantly reduced. The new Top Runner program in Japan implemented standards that has resulted in significant improvements in energy efficiency since its inception. As the world becomes more and more focused on power efficiency, regulatory agencies put increasingly stringent requirements on household applications. Energy-efficient components and design for white goods is required for leading product design. Appliances have a number of different motors to control different functions, as shown here. Each of these are areas where improved efficiency is important. Depending on applications and functions, different types of motors are used. What are the common challenges that an engineer would face? Along with the trend for green power applications, a low power and highly efficient device is required for motor driver ICs. The engineer would look for motor drivers providing the best efficiency for the most amount of cooling required. If the fan driver board is inside the main compartment, heat is generated by the components and extra power is required to compensate. Low noise is very important for the homeowner. Reducing noise generated by motors in white goods is an essential element of the design. Electronics that help the motor run a little smoother and thus have less noise would be a good choice. To maximize the available storage space of a refrigerator requires that motors and their electronics occupy less space. A smaller motor with an efficient driver IC can help. Safety also becomes important because for motors to be more efficient, a higher voltage is also required, sometimes up to 600 volts. The brushless direct current BLDC motor is becoming the standard solution for all of the above attributes. We will now look in detail at each function within the applications to better understand their unique requirements and how to optimize efficiency in each one. As you can see, these white goods span a broad range of output currents as well as high voltage requirements, and motors and their control ICs must be able to optimize each of them. Let's talk specifically about refrigerator applications. Even basic refrigerators have a compressor motor and a coolant flow pump. Higher-end products utilize motors for airflow adjustments through the use of fans and dampers. The ice maker might use two motors, one to dispense the ice and the second to empty the ice tray. The block diagram shows the basic building blocks for these applications, with the green boxes indicating where ON Semiconductor can provide solutions. You can see the large number of motor drive ICs that are required to drive these applications, circled in red. These vary from the low end, with just the compressor motor, to a high end with as many as 5 or more motors. ON Semiconductor offers solutions for all of them. All refrigerators have compressors. Newer compressors are using a brushless DC motor design operating in the 600-volt range. As a result, designers need to implement DC motor control and power solutions that provide high current output and high efficiency, but not at the cost of high temperatures. High current output solutions are typically created using a large quantity of discrete components, which not only require a large amount of board space, but also require greater heat dissipation due to increased thermals. ON Semiconductor offers Intelligent Power Modules, or IPMs, for three-phase motor control. These IPMs use the ON Semiconductor unique insulated metal substrate technology, IMST, which offers high efficiency, high reliability and safety, often with an overall BOM cost savings. These motor drivers utilize hybrid IC technology, which provides the highest current output solutions on the market today. Compared to traditional discrete solutions, ON Semiconductor's IPMs provide a smaller component count, reduced board space, increased reliability, and lower heat dissipation. ON Semiconductor offers the STK551U362A-E, which is a 10 amp device, the STK531U3X2XE, which is a series of devices from 5 amps to 10 amps with one shunt resistor. We also offer devices with 3 shunt resistors. These are the STK554U362AE, which is 10 amps, and the series STK534U3X2X-E, which is 5 to 10 amps. In the refrigerator, automatic ice maker applications, brushed motors are used for 2 functions. One is to open and close the water supply valve that fills the tray, and the other to flip the tray once the water is frozen. Both of these functions can be realized using an H-bridge driver. The high-end refrigerator may also have a motor to dispense the ice out of the front. The motor driver for the ice maker needs to be robust, efficient, and small to fit into a constrained space available. By using a product like the LB1948MC, a dual H-bridge driver from ON Semiconductor, only one device is needed, and with a standby current of less than 1 microamp, it will not melt the ice it helps to create. Likewise, the LV8548M from ON Semiconductor is a 2-channel, low saturation voltage, forward-reverse motor driver. It is optimal for motor driver in the 12-volt system and can drive either 2 DC motors, or 1 DC motor using parallel connection, or a stepping motor in full step and half step operation. A motor driver from the LV873X family can also be used to control the water supply to the ice maker. For ventilation and cooling, a 12-volt BLDC fan motor is used. 2 fans are now common. One fan is used for cold air circulation inside the refrigerator. The other fan is used for heat sink cooling outside the refrigerator compartment. In these types of application designs, it is important to be able to use highly efficient sensorless motor drivers that are easy to implement. The LV8804 and 8805 and the LB11685AV from ON Semiconductor are 3-phase drivers optimized for low power consumption and low vibration. These drivers do not require Hall sensors, enabling a reduction in the size of the motor. The soft booting function enables quiet startup stability. The integrated soft switching function provides very quiet motor operation. A lock protection function protects the driver by disabling the output when the motor stops abnormally. A refrigerator uses a motor to control a damper to adjust the temperature inside the non-freeze section. If the temperature is getting too high, the damper opens a little further to allow more cold air to enter from the freezer. High-end refrigerators have several temperature-controlled zones. Each of these will need a motor to adjust the opening size of the damper. Because of the position control, a stepper motor is often used. The LB1948MC from ON Semiconductor is easy to design in, and their standby current is almost zero. The LV584M from ON Semiconductor is a 2-channel, low saturation voltage, forward-reverse motor driver. The package size is the smallest in the industry, reducing the PCB drastically. This makes the product extremely design-friendly because it requires less external components and less board space to operate efficiently. Using an energy-efficient damper will enable a power-saving refrigerator solution. ON Semiconductor not only makes motor drive solutions for white goods, but makes many parts that can be used in a refrigerator application, from microcontrollers to touch sensors and everything in between. This block diagram of a refrigerator shows the functions that we have solutions for, integrated in green. The pink color blocks of the diagram highlighted the motor driver applications. The high voltage tolerance of these products provides safe solutions. Let's move on to air conditioner applications. The indoor air conditioner unit often uses 2 motors, one for the fan and one for the louvers to control the airflow inside the room. The outside air conditioning unit consists of the compressor, the fan, and valves. High-end models will have an auxiliary fan. The unique requirements of these end applications provide multiple opportunities for ON Semiconductor motor drivers to improve the product efficiency. Within air conditioner units, 3-phase BLDC fan motors are used for both DC fan indoor and outdoor units. The drive voltage can be up to 250 volts, and the design requires a 600-volt device to ensure it is robust enough to handle noise spikes that occur. A 1-amp fan is used for the indoor unit. A 2-amp fan is typically used for the air handler within a large split system, and a 3-amp fan is used for the outside unit. Air conditioner motors are driven by high voltage that are required to be highly efficient and silent in order to provide a positive consumer experience. In order to optimize efficiency and to keep noise at a minimum, we recommend a product like the LV8136V, a PWM drive from ON Semiconductor, which is a 3-phase Hall sensor controller. In this simplified block diagram solution, we show a combined solution of the LV8136V with an IPM module of the STK611 or STK5C4 series to provide a silent, robust solution with minimal component count. This high level of integration will increase reliability, and the power-saving mode will take the standby current to almost zero. We recommend for the indoor unit, the automatic filter cleaning use a stepper motor, while the louver position can be a low-cost forward-reverse brush motor. The fan in new efficient models are a variable speed 3-phase brushless motor. The outdoor unit usually has a highly efficient 3-phase brushless motor for the fan that blows on the coils. The complete air conditioning block diagram shows that ON Semiconductor has solutions for almost all of the components. Let's move on to washers and dryers. Washing machine and dryers. The washing machine requires motors to drive the drum, the water pump, and different valves. The dryer needs motors for the drum and the air blower. Within a dishwasher, motors are needed for pumps, fans, arms, and valves. All of these different applications, from refrigerators to dishwashers, have different requirements for voltage and current. Within the washing machine, the drum driver must drive the largest motor, typically in the 10 amp range. The ON Semiconductor Integrated Power Module, or IPM, for 3-phase BLDC motors is the most advanced product series covering the requirements. This integrated solution provides high efficiency, excellent heat dissipation, robust design, and reliable operation. As with air conditioners, noise is important to customer satisfaction, and these products provide a silent drive with high efficiency, durability, and built-in thermal protection. These drivers come from either a single shunt resistor or with 3 shunt resistors, depending on your requirement. Washing machines require a drain pump. This is often a 24-volt, 3-phase brushless motor. The LB11920 is a direct PWM IC for 3-phase power brushless motors operating over a wide voltage range from 9.5 to 30 volts. The duty cycle is controlled by a PWM signal. The LB1975 is a similar 3-phase brushless motor IC, also with direct PWM control, operating over a higher voltage range of 20 volts to 42 volts. Within the washer and dryer, a motor is required to move the damper that controls the dryer's airflow. This damper is similar to the type used in the refrigerator. An H-bridge driver and a 2-channel motor are typical. For the damper, ON Semiconductor offers highly efficient motor drive ICs. Products like the LB1948MC are easy to design in and offer standby currents of almost 0. The LV8548M is a 2-channel, low saturation voltage, forward-reverse motor driver. The package size is the smallest in the industry, reducing the PCB significantly, and it is designer-friendly because it requires less external components. The fan blower is similar to the type used for air conditioners. These motors are driven by high voltage, require high efficiency, and must be silent. To optimize efficiency and low noise, we recommend the LV8136V, a PWM driver, which is also a 3-phase Hall sensor controller. In summary, ON Semiconductor offers a variety of motor drivers for white good applications, along with a large portfolio of complementary products to meet the unique needs of these applications. ON Semiconductor's integrated power modules and insulated metal substrate technology devices, also known as IMST devices, cover high current, replacing direct solutions, reducing component count, and increasing reliability. The ON Semiconductor website has numerous block diagrams helping to provide solutions for all of your design needs in a variety of end applications. ON Semiconductor has a complete portfolio of devices which addresses all of the essential building blocks of today's application design. For more information about motor drivers from ON Semiconductor, please contact your local ON Semiconductor sales representative or authorized distributor partner, or visit our website at www.onsemi.com. Thank you.